The night did not scatter galaxies like dice across a table. It drew them into lines, braided them into bridges, set them burning at the crossings. Astronomers watched sky maps bloom with patterns that should have been noise and felt their breath catch. Arcs of galaxies tracing invisible highways, clusters clumping at junctions like cities at river mouths, oceans of darkness yawning between them. On the largest scales, the universe revealed a secret architecture, a lattice so vast that calling it structure felt timid. This was a web, a net cast across creation, and every spiral and every quasar hung upon its threads. What you are about to see will change how you think about the universe. The glow we call the cosmos is only the paint. The canvas underneath is dark matter, a ghost scaffold that neither shines nor scatters light, yet tugs on everything with quiet, relentless gravity. Along those unseen beams, ordinary gas streams like fog pulled into valleys, cools, and ignites into stars that sketch the hidden lines. Galaxies do not wander. They are guided. Their orbits bend toward the busiest intersections. Their tails point like weather vanes in a wind you cannot feel. And their histories are scribbled in a script written by the pull of the web. Look near home, and you can sense the current. Our local group, the Milky Way, Andromeda, and their retinues, drifts not as a solitary fleet, but as a convoy piloted by filaments curling through a larger basin of attraction. Push your gaze deeper, and you find lighthouse quasars blazing at ancient distances. Their light combed and tinted by strands of intergalactic gas they pierce along the way. Even the emptiness has a shape. The voids are not mere gaps. They are ballooning caverns whose expanding walls squeeze matter into sheets and then cinch those sheets into shining cords. It is as if the universe learned the craft of lace, loop by loop, from the first seconds after its birth. This should be impossible, you think, because nothing so delicate should survive in a cosmos that once churned like a furnace. Yet the pattern persists, patient and stubborn. Imagine a lake freezing from surface to shore. Tiny ripples stiffen into ridges. Ridges meet into ribs. Ribs knit into plates. The cosmic web grew with the same quiet inevitability. From minute wrinkles in the early fireball, gravity pulled thread through thread until the tapestry stretched across unfathomable distances. Ordinary matter merely lit the contours, candles taped along a scaffold no eye could otherwise see. And the scale. You can hear it when astronomers whisper the figures to themselves. Filaments reach across gulfs that swallow superclusters. Nodes, where many strands cross, boil with gas heated to tens of millions of degrees. Bright in X-rays, loud in radio. Between the shining cities, the bridges shimmer with a thinner, warmer haze, a pantry for galaxies that are still hungry. Flow follows slope, like rain racing down a mountainside. Hydrogen streams along the spines, hurrying toward deeper wells, feeding what waits at the crossings. If you listen closely, the background hum of the universe carries the echo of this design. The afterglow of the Big Bang wrinkles just so. The motions of nearby galaxies tilt just so. The way light is bent by mass along our line of sight skews just so. Every clue points to the same conclusion. Something hidden was waiting in the dark, and it shaped where every star would take its first breath. The web is not an ornament laid on top of reality. It is reality's blueprint. Think of it this way. If the universe were a city at night, the dark matter would be the road grid, the interchanges, the long-haul bridges. The galaxies would be the rushes of headlamps and the neon signage that make the map obvious. You are not seeing traffic choose random alleys. You are seeing commuters bound by geography, funneled by design. A galaxy's fate begins with the lane it is born in. Some are spun up by graceful two-lane filaments that feed them evenly for eons. Others roar into crowded junctions and are stripped by storms of hot gas. their star formation throttled by the very throngs that promised opportunity. In the web, location is destiny's first draft. We have learned to trace these strands not by touching them, but by watching their consequences. Place 1,000,000 galaxies on a three-dimensional chart, and the filaments practically burn through the fog of data. Measure how background galaxies are sheared into subtle ellipses, and you can weigh the invisible roads doing the bending. Read the flicker of ancient quasars, and you can taste the thin broth of hydrogen they sip as they pass through sparsely lit corridors. Everywhere, different instruments sketch the same skeleton from different shadows. But even that is only a silhouette. To step closer is to confront a deeper question. How did this network rise from the young universe's trembling? How did it choose its junctions and decide which lanes would widen, which would wither, and which would remain vacant like scaffolding waiting for a building that never comes? The answer will demand we walk backward in time, into an era when the cosmic fireball cooled enough to carry whispers. When quantum seeds were flung wide by a burst of expansion like a balloon inflating unevenly, when gravity began to tug on those seeds with a patience that makes mountain building look like haste. Before we go, a breath of housekeeping within the wonder. For more content, like the video, subscribe, and tell me where you're watching from. Then lift your eyes again. The map ahead is not a map of roads, but of causes. Not a list of places, but of the forces that sculpt them. We are about to follow the threads to their birthplaces. The filaments are humming, the nodes are gathering, the voids are exhaling, and the pattern that set everything in motion is tightening, line by line. And the next step will press us into the moment when the first stitches were pulled and the fabric began to form. Telescopes stare into a young universe that should be smooth like cooling glass, and yet astronomers see a faint tremor etched across the afterglow, a shiver in the light itself. Imagine a pond when the wind first touches it. Ripples appear where moments earlier there was only a mirror. In the earliest breaths of time, quantum jitters, tiny, whispering chance events, were stretched by a violent swelling of space, a balloon inflating unevenly so quickly that wrinkles froze into the rubber. Those wrinkles became seeds of gravity. You are looking at destiny written as faint temperature freckles across the sky. The hidden mass answered first. Dark matter cares little for light. It listens to gravity with absolute attention. Where the seed was slightly denser, it tugged. Where it tugged, it grew denser still. Envision grains of sand on a drumhead. Strike the drum, and the grains slide from peaks into valleys. Strike again, and they pile higher, the valleys sharpening into channels. In the expanding cosmos, the beat was the pull of gravity, and the grains were halos of dark matter, gathering into threads that lengthened as space stretched between them. Ordinary gas lagged behind, dragged by a different chain. For a while it was married to radiation, bounced and jostled by light like dust trapped in a sunbeam. Only after the fireball cooled did the gas slip free, like mist decoupling from a fading wind. Then gravity began to shepherd it toward the same gathering places as the dark matter. The densest pockets thickened, the pressure mounted, and cooling pathways opened. At those crests, gas fell inward, releasing heat like a brake pad burning on a mountain descent. Where cooling outpaced turbulence, the first stellar sparks flared. The shape of growth was not a simple collapse, but a choreography. Sheets formed before filaments, like frost, that paints a window with broad veils before it sketches fine cracks. Those veils thickened along their seams, and the seams were pinched into long cords. At the crossings, matter deepened into knots so heavy that even hot gas struggled to escape. Picture dough folded again and again until strands align. Gluten tightening into a lattice that can hold a city of bubbles. Cosmic gravity kneaded space with the same patience, aligning flows, tightening strands, storing potential in each intersection. As these threads assembled, the universe was expanding. And that expansion was not an enemy of structure. but the stage on which structure learned to grow. Between the chords, empty regions swelled like bread left to proof, pushing on their surroundings with uniform insistence. Those voids were not static holes. They were balloons that enlarged while their walls thinned into broad plates. The plates shed material along their creases. The creases fed the filaments. The filaments drained into the nodes. Everything moved, everything flowed, and the pattern sharpened because each route was the path of least resistance. Energy left fingerprints. Sound waves from the early plasma rang through matter and light like a bell, leaving faint preferred spacings in the galaxy distribution, a ghostly yardstick embedded in the map. Meanwhile, in crowded regions, gas slammed into itself, built shocks, and heated until it glowed in X-rays, a neon sign screaming the location of the deepest wells. In sparser lanes, the gas stayed cooler and thinner, a clear river running downslope toward the crossings, carrying the raw ingredients for future stars. The first star fields did not bloom everywhere. They ignited along the ridgelines, lighting up the hidden beams like frost sparkling where a sunrise slips between trees. Gravity churned faster in those beams because the dark matter skeleton had already shaped the flow. As halos gulped gas, some fed gently, streams sliding in along cosmic gutters that delivered cold fuel straight to rotating disks. Others swallowed too quickly and choked on their own heat, building shock fronts that kept fresh gas at bay like a moat around a citadel. The outcome depended on mass, on the geometry of the lanes, on the timing of the inflow, on the surrounding voids that pressed from all sides. Feedback began to push back. Newborn stars flung winds and ultraviolet light into their neighborhoods, peeling and boiling the gas that had nursed them. When black holes woke in the hearts of young galaxies, their jets became fire hoses that carved cavities in the surrounding medium, the spray ricocheting down the filaments and rattling the pantry shelves. Yet the dark skeleton held. The scaffolding did not burn away because it was built of matter that does not radiate, a scaffolding that only gravity can loosen, and gravity was not in a loosening mood. Across ages, a hierarchy unfolded. Small halos formed first, like villages connected by dirt roads. Those villages merged into towns, their roads widened into highways, their interchanges thickened into clover leaves of glowing gas. With every merger, tidal forces stretched streams of stars like pulled taffy, and the lanes feeding the crossings multiplied. The web learned new routes without forgetting the old ones. The whole thing looked alive. A breathing organ with arteries and capillaries, a network that pulsed even as its frame expanded. Some regions fell behind, isolated by geometry and chance. In the centers of large knots, the air grew too hot, the pantry too thin. Star birth slowed to a stubborn flicker. Out along quieter spans, the pace of life held steady. Blue disks spinning, fresh gas trickling in along dark gutters that never advertised themselves. Farther still, in the swelling emptiness, galaxies wandered with fewer neighbors, their shapes less battered by traffic, their histories written in solitude rather than in collisions. The same web that fed growth also parceled fate by address. Look closely, and you will feel the direction of time as a pressure gradient. From the seeds in the early glow to the bright braids of now, every step favored the river route. What you call structure is gravity gossiping across epochs, passing news from one overdensity to the next. There is weight here, come this way. And matter came, it still comes. Gas still slips along the corridors, halos still coalesce and split and coalesce again. Voids still swell and squeeze their borders into thinner, sharper planes. Stand inside this process and ask yourself a harder question. If the web is the script and gravity the author, how do we read the handwriting when the ink is mostly invisible? The filaments keep writing in the dark. The voids keep pushing from the edges. and the crossings thicken with a heat that veils as much as it reveals. Something essential is present, but out of sight. And the universe keeps setting the stage so that, with the right kind of look, the hidden letters might finally glow. The control room dims, and a wall of the sky exhales into being. Not as stars, not as pretty spirals, but as a pointillist storm of coordinates. Astronomers lean in as if a secret were about to speak. Each dot is a galaxy with its distance pried from the color of its light, a redshift teased from spectral lines that drift like buoys on a swelling tide. Thread by thread, the scatter stops looking random. Bridges appear, river deltas glow, empty basins widen into velvet hollows. You can feel the room hold its breath, because this is not a photograph. This is a contour map of gravity, drafted by millions of witnesses that never met and yet keep pointing down the same roads. Redshift surveys carve depth into the flat night. A prism spreads a galaxy's light into a barcode of elements. The whole pattern slides toward crimson as space stretches between us. Translate that slide into distance, and you stack galaxies like lanterns along the same unseen highways. Lines sharpen, junctions blaze, sheets unfurl like banners, then curl into chords as the data go deeper. It is like listening to raindrops and reconstructing the river that must exist to collect them. You do not see the water, but you cannot miss the drainage. Still, statistics alone do not satisfy the hunger to weigh what does the pulling. Light is loyal to gravity. When mass sits between you and a far galaxy, it bends the path of photons by a hair's breadth, so subtle that only patient mathematics can hear it. Weak gravitational lensing is the art of measuring that whisper. Take a field filled with background galaxies and average their shapes. The randomness should cancel, yet a faint alignment remains, an almost imperceptible lean, as if a breeze moved through glass. Map that lean across the sky, and you get a relief sculpture. Of the dark, a topographic chart of mass that neither glows nor scatters and yet sculpts everything that does. There is a hush the first time you overlay the lensing map on the redshift skeleton. The correspondence is not perfect, and that is the point. You are not tracing starlight anymore. You are weighing the invisible roads beneath it. Where the lensing mountains rise, the galaxy density usually follows. Where the lensing valleys sink, emptiness yawns wider. It feels like lifting a city off its fog and seeing the bridges that kept it together. To reach deeper, astronomers turn to lighthouse quasars, beacons so bright they backlight the fog between galaxies. Their spectra are not smooth. They are scratched by a comb of absorption lines, each carved by neutral hydrogen in some far filament that the light pierced on its way to us. This is the Lyman Alpha Forest, a thicket of shadows that, when stacked from many sightlines, sketches the intergalactic medium in faint ink. Imagine shining a flashlight through 100 miles of mist and reading the density of the haze by the freckles it prints on your palm. That is what the old universe offers, a dossier of tiny bites of light that betray where thin rivers of gas are pooled along the web. Not all filaments are cold and quiet. Between busy clusters, gas compresses and warms into a tenuous broth that glows in X-rays and leaves thumbprints on the ancient microwave afterglow. Those thumbprints are the Sunyaev-Zeldovich effects. Hot electrons jostle microwave photons, nudging their energy upward by a small amount, like a crowd lifting a traveler over a barrier one hand at a time. Stitch together these tiny spectral nudges across large regions, and bridges of hot gas appear between clusters that were once only rumors on statistical maps. It is as if the web's steel beams have started to ring when tapped. There is a ledger problem that haunts the community. Ordinary matter seems missing when you tally stars, cold gas, and hot cluster plasma. The suspicion lingers that a large share lives in the warm, hot intergalactic medium. filaments at temperatures too cool for bright X-rays and too warm for easy ultraviolet signatures. Fast radio bursts provide a new ruler. These are millisecond radio screams from distant sources, and their signals arrive stretched in time, with high tones and low tones staggered by the amount of free electrons they plowed through. Each burst is a lightning strike that counts the fog along the line of sight. Stack many strikes, subtract what our own galaxy adds, and the remainder sketches the diffuse electron budget of the cosmic lanes. You begin to hear the missing matter whisper from the tunnels between the bright cities. Ultraviolet absorption fills in the chemistry. Against bright background sources, ions such as oxygen and neon bite out narrow notches in the spectrum. Those notches measure temperature, density, and enrichment, a census of the pantry that filaments carry to the neighborhoods they feed. Sometimes the lines stack into multiplets that reveal turbulent motion. Sometimes they widen into broad troughs that hint at shocks where bridges meet heavy traffic. Each spectrum is a biopsy of the web's flesh along a single thread. Cross-checks are not a luxury. They are oxygen. Redshift surveys draw the bones. Lensing weighs the bones. Lyman alpha traces the skin. Sunyaev, Zeldovich, and X-rays glow where the bones rub. Radio bursts count the electrons. Ultraviolet lines test the composition. When the pieces agree, confidence tightens. When they do not, the disagreement points a finger at hidden physics, at feedback from black holes or stars that may be stirring the gas, at uncertainties in how light travels through a space that is not perfectly flat. You might think this is an act of remote sensing alone, a craft of extracting cartography from whispers, but the process is physical at every step. Fibers at observatories ferry starlight into spectrographs, cooled like vaults for secrets. Cameras with mosaics of detectors drink the night without blinking, night after night, to catch the faint lensing shear in a blizzard of noise. Radio dishes time fast bursts to fractions of a heartbeat. X-ray telescopes ride beyond the air to listen where the atmosphere would swallow the signal. No single technique carries the crown. The web demands a choir. There are moments in the data when something jolts you out of the console chair. A lensing map reveals a mass ridge where too few galaxies live, like a bridge in the fog that no streetlights mark. A forest of absorption lines along a quasar sightline shows a gap where a filament should run. A silence that could be a void's tongue or a wind that has swept the corridor clean. A cluster pair glows with a microwave bruise stretched between them. The unmistakable handshake of heat, and yet the X-rays are shy, as if the gas were spread thin across a wider canvas than expected. The web resists easy portraiture, shifting its weight just enough to keep certainty out of reach. You are invited to look with both skepticism and awe. Every map is a wager, every overlay a question asked at scale, every null result an arrow toward a corner of physics that might be misdrawn. We are weighing something that does not shine. We are tasting a gas thinner than the best vacuum on Earth. We are listening for bends in light that would make no impression on a mirror held at arm's length. The instruments say the roads are there. The highways hum with heat and electrons. The rivers of hydrogen leave moss on the stones. And yet the picture flickers at the edges, hinting that the architecture we trace may conceal a deeper scaffolding we have not yet named. A framework that will only reveal itself when we dare to press the measurements against their breaking point. In a darkened lab, a cube of space flickers to life on a screen, and then it breathes. At first the glow is a fog, featureless, like milk poured into black water. Moments later, veins appear. Filaments tense, junctions thicken, caverns inflate, and the fog learns geometry. You are watching gravity write, letter by letter, inside a machine that holds a universe made of arithmetic and patience. The architects call these experiments n-body and hydrodynamic runs. But what they have truly built is a time machine that starts with a whisper and asks what kind of shout it becomes. They begin with a recipe harvested from the afterglow of creation. A spectrum of tiny fluctuations, each one a gentle hill or hollow in the young density field. Into a box the size of a modest cosmos, they pour dark matter as countless points, each a grain of weight that feels every other grain's pull. The calculation is relentless. Every grain tugs on every grain. A ballet of attraction computed again and again as the box expands like a balloon inflating unevenly. The code advances the clock in small heartbeats, and with each beat, the pattern sharpens. Valleys drain, ridges rise. Threads lengthen like frost lines chasing the cold across a window. Dark matter's scaffolding forms first because it interacts only by gravity, slipping through collisions without friction. Where the model places a slight excess, halos condense like dew. Between them, filaments stretch like drawn glass, cold and strong, guiding flows into knots that deepen until escape becomes a rumor. When gas physics enters the stage, the picture gains breadth and heat. The simulation lets baryonic matter ride the same slopes, but now pressure fights back. Radiation cools the gas. Shocks ignite along converging streams, and feedback from stars and black holes launches winds that rattle the lanes. The result is not a static sculpture, it is weather. You are invited to picture specific experiments that became milestones. One grew a universe with enough resolution to follow countless halos as they merged into families, teaching astronomers how often small systems are swallowed by larger cousins. Another married gravity to hydrodynamics with ferocity, letting supernovae and active galactic nuclei kick the gas until it learned to circulate, quench, or replenish disks in a way that resembled the sky we see. A later generation refined the chemistry, tracking metals forged in stars as they washed along filaments like dye in mountain streams, staining the nodes with the memory of earlier generations of fire. Validation is the gauntlet. A simulated night must earn its stars. Teams extract mock galaxy catalogs from their boxes, painting light onto dark matter halos with recipes tuned by observation. They measure two-point correlations, the statistical handshake that says how likely galaxies are to have neighbors at a given separation, and compare the curve to real surveys. They count clusters as a function of mass and ask whether the ledger matches what X-ray and lensing instruments find. They compute filament thickness distributions, void sizes, and the shapes of halos, then lay those statistics beside data harvested from the deep sky. When the curves agree, a rush of relief moves through the room, the feeling that the code has heard the universe correctly. Disagreements are sharper lessons. Some runs produce too many small satellites compared with what telescopes draw around large spirals. Others grow inner density peaks that are too steep, sharp cusps where observations hint at softer cores. Feedback prescriptions are adjusted, as if tuning the vents in a furnace to keep a building comfortable without cracking the windows. Star formation efficiencies are dialed. Black hole jets are given longer or shorter tempers. Winds carry metals farther or let them fall back sooner. Each change leaves fingerprints not only on galaxies, but also on the intergalactic medium that threads the web. Too violent a wind and filaments become anemic. Too gentle and nodes grow obese with stars they should not own. Hydrodynamics is a battlefield of choices. Some codes use grids that capture shocks, like breakers striking a seawall, locking down fluid instabilities with surgical crispness. Others use particles that move with the flow, preserving mass and following streams into the bellies of halos as if riding in their blood. Hybrid methods emerge, borrowing strengths from both, teaching the gas to curl, shred, and cool with a grace that makes observers nod. Radiative transfer joins the dance, letting ultraviolet light from newborn stars carve ionized tunnels through the fog, opening channels that change how quickly future generations can ignite along the spines. Out of these universes in boxes come synthetic skies so convincing that you can forget they were born of code. Mock lensing maps bend background galaxies exactly as mass ought to. Simulated quasar sightlines carry a Lyman alpha forest with the same gnawed cadence as the real spectra. Microwave maps show bruises where pairs of clusters squeeze hot bridges, and X-ray images from the run's pulse with cavities blown by central engines that look uncomfortably like the bubbles seen by orbiting observatories. It is not mimicry for vanity's sake. It is a crucible where hypotheses are burned until the slag falls away. Yet the closer the match, the louder a question presses on your mind. If a simulation can be taught to resemble the sky by turning the dials on subgrid physics, the unresolved, chaotic processes that must be summarized rather than followed atom by atom. How much of the success is truth, and how much is skillful approximation? You feel the edge when you compare environments. In sparse filaments, cold flows that should slither into halos sometimes break apart if the numerical viscosity is wrong. In crowded nodes, cooling flows that ought to drown galaxies can be arrested by black hole feedback in the code. But the energy required is a confession about our incomplete understanding of how accretion couples to its surroundings. The web, even in silico, asserts a deeper law: connectivity governs destiny. Hollows fed by many strands grow heavier and spin differently from those with only a few umbilicals. Galaxies living at intersections are battered into spheroids by mergers and hot atmospheres, while those on quieter roads keep their disks and blue hearts. Simulations catch these trends and quantify them, but they also expose borderline cases that keep theorists awake. There are systems on the cusp between feeding and quenching, where small changes in filament orientation or void pressure flip outcomes like coins. There are filaments so fat with heat that they seem to quench galaxies upstream, a kind of environmental embargo written into the road itself. What unsettles most is the way certain tensions refuse to evaporate. On the largest scales, the boxes sing harmony with the observed web. On the smallest, they hum in a key that might not be the one the universe prefers. Some suspect that dark matter might possess a whisper of self-interaction, softening cores and thinning the ranks of satellites. Others argue that feedback, properly resolved, could sculpt the same solutions without rewriting what the dark is. Each new run pushes the resolution finer, the volume larger, the physics deeper, and each triumph opens a fresh seam of doubt, as if the code were holding up a mirror that shows a face nearly our own, and yet with a shadow where an eye should be. A shadow that waits for a light we do not yet know how to shine.
Night after night, the map grows veins. You can trace them with a fingertip against the dome of the sky. Not by starlight alone, but by the way matter moves, the way light bends, the way heat lingers where traffic converges. Filaments announce themselves first, long and taut like suspension cables stretched between titans. They are bridges on scales that dwarf superclusters, corridors where gravity has taught gas to behave like a river in flood season. Along their spines, velocities align as if every atom has read the same memo. Head downstream. Galaxies entering these lanes feel a nudge become a current become a pull become a fate. Their disks tilt to catch the flow, their halos breathe deeper. Their star birth brightens or dims according to the temperature of the road beneath them. These bridges are not uniform. Some are cool and slender, the temperature of a spring night by cosmic standards, carrying clear streams that slide into halos without shock. Others are swollen and fevered, warmed by the crush of traffic and the turmoil of mergers at their ends. In those overheated lanes, the gas is restless, threaded by weak magnetic fields and tangled turbulence, a wind tunnel where star-forming fuel can be shredded into tatters before it reaches a waiting disk. You can hear the difference in the spectra. Cold filaments whisper in narrow lines. Hot filaments hiss in broader strokes, the signatures of ions that have felt the slap of shocks. Connectivity is the rulebook. A halo with many bridges attached gains weight faster and spins with a character stamped by the way its feeders meet the rim, like a mill pond that turns quicker and steadier when more sluices are open. Follow the bridges to their crossings, and the landscape leaps into another register. Nodes are where filaments knot, the deepest potential wells for hundreds of millions of light years around. Foundries where gas is pressed into a state so hot that it glows in X-rays and rings the microwave background with a measurable bruise. The intracluster medium bubbles at temperatures that would melt any ordinary matter into plasma instantly, a sea of ions into which galaxies plunge like swimmers in scalding surf. Here the physics grows crowded and loud. Ram pressure strips gas from spirals as if a hand pressed flat against their faces. Tides stretch and shear stars into streams that wrap the cluster like gauze. Encounters heat orbits and thicken disks into ovals. The environment is a refinery with no off switch, and every orbit is a pass through a blast furnace. At the centers of many nodes, black holes act like industrial engines, swallowing matter and returning a portion of its energy as jets that carve voids in the hot atmosphere. Those cavities rise like balloons through the plasma, dragging cooler gas behind them, stirring a circulation that can either feed or starve the galaxies that created the storm. You can watch the feedback in concentric ripples, sound waves and X-rays that carry a pressure beat across the cluster. It is weather inside gravity's bowl, and the forecast depends on how often filaments deliver fresh fuel, how strongly the central engine spits it back, and how the competing flows negotiate their truce. Step back a little, and the nodes are not isolated cities, but traffic circles that tell the bridges how to enter and leave. Filaments rarely meet in simple pairs. They arrive as bundles, their orientations setting the spin of the aggregate and the fate of anything that tries to pass. Galaxies on inbound lanes flare with star formation if the road stays cool, or fade if the heat at the outskirts throws a shock that arrests inflow. Morphologies record these trials. Dense neighborhoods prefer spheroids, the battered survivors of mergers and harassment, while quieter outskirts host spirals with blue hearts still fed by slender tributaries. The web is not a background, it is an active zoning board. Outside the bustle, walls stretch broad and pale, sheets of matter that girdle the voids like continental shelves. They are not as dense as bridges and not as hot as knots, but their breadth makes them powerful. They gather the drifts from many directions and then shed material along their creases, feeding filaments with a steadiness that belies their appearance. The flows across walls are coherent, like winds sweeping an open plain. Galaxies here feel a gentle push rather than a shove, a bias in their motion that aligns spins with the local topography, the way a field of grass leans under a persistent breeze. And then the caverns. Voids are the negative space of the cosmic sculpture. Expanding basins where matter is scarce and motion is organized by evacuation. Within them, galaxies are fewer, smaller, bluer, shaped more by solitary evolution than by collisions. Outflows are smooth, a calm exhale that presses on the surrounding walls, sharpening their edges and tightening their folds. In these places, a single infall or a modest trickle can rewrite a history because there is so little competition and so much time. The quiet is not emptiness. It is a bias toward gentler lives, experiments in evolution run at low density and slow cadence. Between all these terrains, a quiet rule repeats. Alignments reveal ancestry. Spins of galaxies tend to lean along filaments when halos are light and flip to perpendicular as halos grow heavy, a sign that angular momentum arrives first by smooth streams and later by clumsy mergers. Satellite constellations recall the lanes that delivered them, arranging themselves in planes that echo the old highways. Even stellar streams in the halos of big spirals can remember the direction of their last descent, threading the outer darkness like ghostly signage pointing back to vanished ramps. Temperature and entropy track the bookkeeping of energy. In nodes, gas climbs to high entropy, a badge of heavy processing, while in filaments it keeps a leaner ledger, a record of gentle delivery occasionally scarred by shocks. Metals trace the path of enrichment. Heavy elements forged in stars leak from galaxies as winds and are caught by the web, staining nearby lanes and walls with a memory of prior generations. Void gas stays cleaner, like a well far from roads, though not untouched. Even there, faint striations hint at ancient passages. If you listen long enough, the web talks in a language of flows. Matter moves along gradients of potential like rain obeying gravity, but heat and pressure can redirect, delay, or deny passage. A bridge made too hot by activity at a node can smother star formation upstream. An embargo enforced not by politics but by plasma. A wall squeezed by an expanding void can shed a new filament, rerouting supply lines across millions of light years as casually as a river cuts a new channel during a flood. Nothing is guaranteed except that geometry sets preference and preference sets fate. Where does that leave you, standing between the burning knots and the silent hollows? With a map that is precise enough to guide predictions and blurred enough to hide surprises. With a rulebook that works in most districts and a handful of neighborhoods where the rules bend. With alignments that whisper origin stories and counterexamples that refuse to sit neatly in the family tree. The anatomy is clear, the physics persuasive, and yet the very clarity exposes fractures where a different ingredient, a different coupling, or a different kind of dark might be shaping outcomes unnoticed. A suspicion that slips along the bridges, curls in the hot lungs of the nodes, and breathes out of the voids as a question we have not yet learned how to frame. Watch a blue spiral drift toward a filament like a ship approaching a hidden current. Its outskirts are dim, its core a steady ember, its future balanced on the temperature of a river you cannot see. Then the infall begins. From upstream, threads of gas slide along the spine of the bridge, narrow and clear, colder than the roaring furnaces of cluster air, cool enough to keep their discipline as they cross the halo's border. This should be impossible, you think, because a galaxy's gravity ought to squeeze and heat any visitor until it glows and stalls. Yet the stream dives like a spear through warm layers, a cold vein that refuses to clot, delivering fuel to the inner disk where molecular clouds can form and collapse. Stars flare to life as if someone opened a gate and let rain into a drought valley. Cold mode accretion is not a drizzle. It is a set of arterial lines. Along each, gas stays below a critical fever, avoiding the shock that would otherwise turn it into a halo of indecision. The stream carries angular momentum as well as mass, twisting the disk into alignment with the approach, teaching the spiral how to spin. In the plane of the galaxy, lanes of star birth light up like city blocks, bright knots marching along arms that have found their pantry restocked. If you listen to the spectrum, you hear the narrow breath of cool hydrogen, the fine sibilance of oxygen and carbon in clouds that have not yet felt a furnace. The galaxy inhales and answers with blue light. Not every traveler has this luxury. Grow the halo heavy enough, and infall slams into a shock at the boundary, a standing wall of heat that turns fresh supply into a vast, simmering reservoir. Gas then waits in quarantine, cooling by slow radiation, pooling in eddies that may never reach the disk unless something stirs the pot. The star formation heartbeat falters. Without a shortcut through the hot shell, the galaxy starves even while sitting inside an ocean. This is strangulation by temperature, a blockade enforced not by neighbors, but by the halo's own weight. Where the bridges meet in crowded districts, the weather grows violent. A spiral plunging through cluster air feels a windstorm, even on a windless day, because its speed turns still plasma into a gale. Ram pressure reaches underneath the disk and peels gas away like a tablecloth pulled from beneath a feast. Tails of stripped material stream behind the galaxy, glowing in H-alpha like a wound transmuted into a flag. Without its gas cushion, the disk stiffens. Star formation collapses in the outskirts first, then retreats toward the core, a candle guttering from the edges inward. Harassment compounds the damage. High-speed flybys jolt orbits, thicken disks, and spark brief, desperate bursts of stars that burn through remaining reserves. Tidal forces pinch and stretch, leaving loops of newly minted suns flung into space as if the galaxy were shedding memory. Every encounter is a vote against the quiet growth that cold flows once promised. The morphology begins to tilt from graceful spiral toward rounder, featureless forms, the natural grammar of a life lived in traffic. Black holes turn the environmental script into personal drama. Feed one in the nucleus of a massive galaxy, and it answers with jets and light that couple to the surrounding gas. In cool core clusters, where a central atmosphere wants to condense and rain onto the brightest galaxy, the engine punctures the medium with twin cavities, launching sound waves that carry energy across hundreds of thousands of light years. The rain hesitates. Sometimes the engine stutters, allowing a brief downpour that ignites a ring of star formation close to the center, a storm around a lighthouse. Then the jets roar again, and the faucet turns off. This on-off rhythm regulates a metropolis. Out along quieter filaments, you can watch the opposite rhythm, smooth fueling that never quite becomes a flood. Streams braid into the outskirts and pour into the disk through narrow inlets, preserving rotation, building thin, elegant arms. Here a galaxy can ride the main sequence of star formation for a long span, balancing inflow against feedback like a practiced breath. Supernovae stir the interstellar medium without blowing it apart. Fountains rise and fall, enriching the disk with metals while leaving enough cold gas to sustain youth. Alignment with the filament matters. When the stream meets the disk in harmony, the handoff is graceful. When the geometry is skewed, turbulence thickens and the handoff spills, feeding the halo more than the heart. Address decides tempo. In walls and filaments with moderate density, quenching is rare and late, usually brought by mergers or by a gradual shift in the halo's ability to cool. Inside the roaring nodes, quenching is common and early, enforced by heat and speed and engines that refuse to sleep. Between these extremes live the most telling edge cases, galaxies perched on the verge. They sit at the edge of a filament that has been warmed by recent activity in a cluster, or they linger in the wake of a past merger with a halo just heavy enough to sustain a shock. A slight change in the temperature of the lane, a small swing in angular momentum, and their futures split into two contrasting biographies. One becomes a quenched spheroid with a red heart, the other keeps its blue pulse. You can tease out these stories in the way galaxies lean. Spin axes in light halos tend to align with their nearest filaments, evidence that they were spun up by the same streams that fed them. In heavier halos, the spin flips toward perpendicular, a sign that mergers have taken the wheel. Satellite systems and stellar streams retain a memory of the ramps they used to enter. They arrange themselves in planes and arcs that echo the approach lines of long-vanished supply routes. Even the chemistry remembers. Metal pore inflow can revive a disk star formation while diluting its central metallicity, a breath of mountain air, into a smoky room. Metal-rich fountains lift heavy elements from the disk into the halo, where they cool and fall back as a drizzle of enriched rain, complicated weather in a layered sky. Now sweep your gaze to the outskirts of a giant cluster where a fresh bridge joins the circle. A convoy of galaxies rides the lane, their leading edges bright with compressed gas, their wakes long and ghostly. The bridge itself carries a thin, hot sheath from the last merger, a jacket that insulates and irritates at the same time. Upstream, a smaller node is approaching, its own central engine rumbling, its influence reaching along the corridor like heat felt before a fire is seen. The stream that once fed quietly now shimmers with turbulence, its cross-section changing, its delivery schedule slipping out of phase with the needs of the disks waiting downstream. What happens when a roadway that taught galaxies to live becomes a lever that teaches them to fade? When the corridor that once whispered growth begins to mutter a different instruction set, written in heat and pressure and boundary shocks that creep outward along the spine. The filaments pulse, the nodes answer, the cold veins narrow, and the next breath you expect a spiral to take catches in its throat, held by a hand you cannot see yet can measure in every line of light. The map zooms, the grandeur tightens, and the highways of creation flow toward a neighborhood with a familiar glow. Our spiral is not anchored in isolation, it rides a current. The Milky Way and Andromeda drift together like two lanterns lashed by a hidden rope, their satellites trailing as if tidewater pulled them through a channel carved in the dark. You can feel the motion in the background itself. The afterglow of the early fireball looks warmer in one direction and cooler in the opposite, a dip across the sky that betrays our travel through the cosmic sea. A wind on the face you can only sense by the way ancient light tilts against your cheek. Follow that tilt, and you meet a basin of attraction with a name that sounds like a continent. Lania Kea, an expanse not drawn by borders but by flow lines, gathers thousands of galaxy streams into a shared downhill. Within its catchment, peculiar velocities point like reeds bent by river water, carrying small groups and massive clusters toward a gravitational lowland that pulls without announcing its full ledger. You live inside this hydrography, and your address is written as much by the direction you travel as by the coordinates you occupy. Trace the currents on finer scales, and a sheet appears, a flat raft of nearby galaxies sliding together with gentle coherence. This local sheet is a quiet road where the Milky Way and its companions share similar motions, as if nailed to the same plank. Below the plank yawns an emptiness with a personality. The local void pushes from beneath, its under pressure nudging the sheet like a rising bubble lifting one side of a raft. Outward flows escape its boundary, strengthening the sense that absence can sculpt destiny as powerfully as presence. You are both pulled by what lies ahead and urged along by what lies behind. Lift your eyes along the sheet, and the current strengthens toward a murky convergence, known for its discretion. Far from dramatic fireworks, the great attractor lurks behind curtains of dust in our own galaxy's plane. A gravitational weight spread across the Centaurus and Norma sectors that gathers traffic from absurd distances. Even without a clear photograph, the flows confess its influence. Velocities tilt toward it. Clusters feel their paths bow. The basin deepens in models that reconcile motion with mass. It is less a single mountain than a range, a confluence of knots and ridges whose summation writes a command that many obey. Closer to home, the two lanterns test their rope. The Milky Way and Andromeda are falling toward one another along a lane that threads the local group, pulled not only by mutual gravity, but also by the gentle persuasion of the wider web. Their approach is not headlong chaos, but a choreography shaped by filaments that feed both halos. Streams that once delivered fuel now also deliver momentum, and the dance partners carry retinues that remember their separate roads. On starry nights, you can imagine their halos already overlapping like the breath of two swimmers closing distance underwater. This neighborhood holds quieter signatures of the web's handwriting. Consider the planes drawn by our satellites. Around the Milky Way, many dwarf companions trace a slanted sheet more organized than chance would suggest, a fossil of arrival routes along which they were funneled. A similar geometry appears around Andromeda, as if the same family of bridges fed both cities. Stellar streams arc through our halo like torn silk, the remnants of smaller galaxies stretched beyond recognition by tides, and then woven into long ribbons that remember the direction from which they fell. Even within the disk, the alignment of outer gas and the warp of the farthest stars can be read as a response to persistent off-axis nudges from the surrounding lanes. The gas above and below our plane carries further whispers. High-velocity clouds rake the outskirts with speeds too large for casual weather, their origins debated between fountains that rise from inside and inflows that slide from without. Some show metallicities hinting at recycled material. Others taste too fresh, as if they sampled reservoirs that never belonged to us until the web delivered them. The halo glows faintly in X-rays, a bath warmed by past feedback and present accretion, a medium through which future supply must travel. Every tracer is a vowel in a language we are still learning to pronounce. Turn to the awkward truth of motion. A galaxy's redshift is not only expansion. It carries the imprint of peculiar velocity, the extra speed gained by falling toward a basin or fleeing a void. Surveys that measure distances independently of redshift, by the brightness of certain standard candles or the detail of resolved stars, can separate those two components and draw flow lines across our region. The picture that emerges looks like a weather map. Arrows stream toward the Centaurus complex, arc around the Perseus and Pisces assemblages, spill across saddles between basins, and curl around voids like wind skirting high-pressure domes. The local group sails on one of these streams, its bow aimed by a pressure pattern we can measure yet hardly control. Even the quiet microwave wind on our face is not only the solar system's dash through space. Layers of motion add like nested rivers. The Earth around the Sun around the galactic center, the Milky Way inside the local group through the sheet inside the basin. The final vector points roughly toward the same quadrant where flows deepen and knots pile, a consistency that feels like a verdict. Your sky has a preferred direction because your neighborhood belongs to a larger river. Pieces of the map are missing, as if fog still clings to certain bends. The zone of avoidance, where the dust of our disk thickens the air, hides whatever webbing crosses behind it. Radio surveys and infrared campaigns peer through the smoke and reveal clusters and filaments that almost escape the census, structures that change the balance of the tug-of-war by amounts that matter. Each new discovery reshapes the basin lines by a hair, shifting our understanding of how the local current coils. There is a more intimate unease near the edges of our halo. Some satellite galaxies race in directions and at speeds that hint at past encounters along unseen tributaries. Others appear quenched despite a distance from our disk that should spare them the worst tides, a clue that pre-processing along filaments or inside earlier groups left them scarred before they arrived. Meanwhile, the stellar halo shows shells and chevrons that betray ancient mergers, ripple patterns that propagate for ages in a medium as large as 1,000,000 light-years across, a memory palace written in starlight. You are not a static observer staring outward from a balcony. You are a passenger aboard a ship within a flotilla, all of you drawn by a deep river beneath the keel and pushed by a hollow swelling behind the stern. The compass needle on every measurement leans the same way, and yet the strength of the pull, the part played by hidden mass behind dusty curtains, the exact route carved by filaments that slip just beyond direct sight, all remain a half-heard melody. The flow quickens, the rope between the twin lanterns tightens, and the background wind across your face grows steadier, as if the river were narrowing into rapids whose shape you can sense but not yet chart. The current narrows, the rapids hiss, and the universe leans forward as if about to speak its real name. On this stage, the web is not scenery. It is the instrument we use to test the score. Every strand becomes a ruler, every hollow a lens, every junction a laboratory where gravity, gas, and time argue in public. You are invited into the argument. What you are about to weigh is not only matter, it is the strength of the law that binds the night. Begin with the faintest bend in light. Weak lensing across vast fields records a chorus of tiny shears, background galaxies tugged into near ellipses by mass in front of them. The pattern of those shears across many angles becomes a fingerprint for the growth of structure. If the expansion of space is sped by a dark pressure, filaments thicken at a pace that can be timed. If gravity itself deviates from the textbook in the wide and the weak, the timing slips. The web turns into a chronometer. Measure the clustering of galaxies at many epochs, compared to the lensing of the same regions, and you hold a stethoscope to the pulse of cosmic law. Voids add a second voice, a bass that carries farther than expected. Their interiors are smooth and underdense, yet their boundaries gather stress like drums stretched tight. When a void lenses, the effect is delicate and clean, unpolluted by the messy physics of star formation. Chart the shapes of many voids, stack their lensing signals, and you capture a test of gravity that sidesteps the crowded downtowns of clusters. If a hidden force screens itself in dense places yet whispers in the open, the hollows will hear it first. The quietest rooms in the universe become the most eloquent witnesses. There is a ledger problem that will not sit down. Ordinary matter tallied in stars and cold gas comes up short compared with the amount required by the microwave afterglow and by nucleosynthesis in the earliest minutes. The missing share is not lost. It is dispersed as a warm, hot intergalactic medium. Filaments of gas at temperatures between the comfort of star-forming clouds and the scald of cluster seas. You can chase it through ultraviolet absorption, through subtle X-ray lines of oxygen and neon, through the dispersion of fast radio bursts that count free electrons along the path. Each technique offers a bead on the string. Tie enough beads together, and the census closes on reality. Miss, and the web keeps it secret while every model that depends on honest bookkeeping begins to sway. The earliest lanterns add pressure from the other side of time. When the first stars and black holes flooded space with ultraviolet light, the fog of neutral hydrogen began to clear. That clearing was not uniform. It crept along low-density corridors and bubbled outward from clustered sources, carving tunnels that linked into highways of transparency. The reionization story is a map of the web at birth. Detect the patchwork of neutral and ionized regions in the glow of ancient hydrogen. Catch the damping of small-scale structure as gas heated and expanded, and you learn whether light traveled preferentially along channels that later fed galaxies in the modern epoch. The scaffolding remembers, the transparency remembers, the tale is one tale. Environment is not decoration, it is a teacher with a heavy hand. If halo mass alone wrote destiny, galaxies in identical wells would share identical biographies. They do not. Lanes with more connections grow heavier halos, but they also deliver shear, heat, and neighbors, each able to change a disk's metabolism. The morphology-density relation is not a slogan. It is a crime scene diagram. Ellipticals populate the nodes not just because of mergers, but because the hot atmospheres their choke supply. Spirals persist along the quieter bridges because streams stay cool and uninterrupted. Void galaxies explore a different syllabus, evolving with fewer collisions, weaker tides, and longer gas depletion times. Untangle nature from nurture, and you learn not only how galaxies live, but also what the web has been whispering into their ears. All the while, the smallest scales hum with unease. If dark matter is perfectly cold and indifferent, halos should contain sharp inner peaks and a crowded zoo of little satellites. Observations paint a softer portrait in many places. Feedback from stars and black holes can punch cores into cusps and sweep satellites clean. Yet the accounting is tight and the parameter space narrow. A whisper of self-interaction among dark particles could smooth the centers without fireworks, but it would also leave marks on the thickness of filaments and the shapes of halos in regions where collisions are rare. The web becomes a detector. Measure the roundness of mass maps in the outskirts of clusters, the alignments of galaxies along thin bridges, the survival rate of tiny halos in the emptiest corridors, and you may catch dark matter in the act of being more than silent weight. Neutrinos, those near weightless drifters, complicate the melody. With mass that is small yet not nil, they stream through the forming web like a warm fog, erasing contrast on modest scales and retarding the growth of detail. Their imprint is statistical but unavoidable. Cross-correlate lensing maps with galaxy distributions and the microwave afterglow. Listen for the slight suppression of power at specific scales. Weigh the total mass of neutrinos with the behavior of the net itself. Particle physics leaves its initials in the weave. New eyes are opening. Space telescopes with cold hearts spread wide fields and collect shapes for weak lensing with a fidelity the ground can envy. Survey cameras sweep the night with relentless cadence, building a living atlas of billions of sources, catching supernovae and tidal flares that light up filaments like flares on a coastline. A wide radio ear listens for fast bursts that tick off electrons between clusters and for synchrotron bridges that betray shocks in the tenuous lanes. Giant mirrors on mountaintops pry into the spectra of dim galaxies at distances that once looked unreachable, measuring motions and metal lines and systems that sit on the slenderest roads. Every instrument adds a layer. Every layer tightens or loosens the net of possibility. With each layer comes a paradox. The maps grow sharper, the agreements more compelling, and yet edge cases multiply. A pair of clusters shows a hot bridge in microwaves, yet whispers only faintly in X-rays, as if the gas is thin and blistering over a width that models did not anticipate. A filament align just so lenses more than expected, hinting at mass that starlight does not count and that gas tracers do not certify. A void stacks into a lensing signal slightly stronger than the textbooks prefer, as if the hollows are pushing with an extra breath. You stand between competing explanations. Physics of feedback not yet resolved, dark matter with a personality beyond gravity, gravity itself with a soft accent that only the widest rooms reveal. What you do next is not a matter of taste. It is a wager on how reality hides. Do you add detail to the recipes of star and black hole fury, hoping that the messy will explain the elegant? Do you grant the dark a new kind of whisper and trace its consequences across the bridges and through the caverns? Do you test gravity against itself with voids as cross-examiners and clusters as hostile witnesses? The web is the courtroom. The evidence is light-bent and gas-warmed and galaxies arranged, and the verdict refuses to arrive on command. The rapids grow louder. The instrument panel fills with steady needles and sudden jolts, and somewhere ahead a bend conceals either a familiar river scene from a new angle or a fork no chart has yet admitted exists.